Another draft physics video presentation. Draft science here on YouTube and such. So, in honor of Google's censorship and horrible treatment of free speech and such, so we'll rag on it. Lots to rag about. I mean, it is just a despicable company. The two owners, the Brim guy and the other guy, again, just lied right from the beginning. Just overtly lied to the American people. Don't be evil was their slogan, and they had an evil plot in store for everybody. Worse than anything Microsoft ever did. And everybody accepted it because they played a psychological game. You know, we're your friend. And so as soon as they're your friend, and as soon as you say hello, you know, it doesn't matter what they get accused of. It's just celebrity. You know, Google became a celebrity and therefore untouchable. You know, just complete bullshit. So anyway, Google, in some tax maneuver, no doubt, some way to make more money, okay, take more out of the system, is now called Alphabet. So they bought some dopey company called Alphabet, I guess, and then decided they're going to make that the parent company. Like I said, no doubt for some stupid tax gimmick. So some dopey company called Alphabet, whatever the fuck that is now Google. I mean, now owns Google technically. And Google controls Android and, you know, that kind of crap. So it's just the same. It's just an insidious, awful, horrible capitalist company, and it's the worst kind of company. It's not like General Electric. It doesn't make something cool. No, it makes advertising. That's what it does. That's its money. All of its revenue is ads. It doesn't make anything doing search engineering. It's not a search engine company. It's a marketing company that's pretending to be these other things to sell you ads, to sell you something it makes money on. So it's selling wagons to sell fish, you know, that kind of gimmick. You know, it's undercutting everybody else's wagon prices because it has made a deal with everybody about who's going to be able to sell fish. And it's just insidiously horrible. Just like I said, Microsoft, you know, looks pale in terms of being a racket by comparison to Google's racketeering. So it's just dismal and sad. So I mean, I probably should put Alphabet as evil. I mean, you know, just even you can just tell what buttholes these people must be if they decide to, you know, fine, you do your reorganization, but they come up with a company named Alphabet. Oh, please, too fucking stupid. Yeah. Ugh. Anyway, alright, so on to Baldy Jerk. Baldy Bigot. Alright, so it's just hilarious. They actually did a conversation with the Westboro Baptist Church, which, you know, I mean, compared to Mein Kampf, you know, their dogma is just as bad. I mean, it's like the Old Testament is essentially the first version, right? I mean, when Hitler was writing his book, that was his first version of Mein Kampf was the Old Testament, right? I mean, you couldn't find more bigotry, more, yes, kill the women and children too, for, you know, just the minorest of transgressions. Clearly lots of racism, lots of everything in the Bible. I mean, it's just a disgusting pile of shit book, and anybody takes it literally, right? I mean, I don't know what they do in Israel now. I mean, I don't know. You know, right? The Old Testament is sort of an old version of the Quran or whatever, the Torah. You know, it's just kind of funny. I mean, I wonder, you know, they must still think homosexuals are dirty, you know. So are you allowed to be gay in Israel? I don't know. Anyway, so yeah, let's just stick to this ludicrousy, right? So here's a guy who complains that he can't talk to me because I don't believe in one aspect of the Holocaust. Yet he'll talk to people who really want one. They're looking forward to the day when all of you get smited and sent to hell. They've got, you know, they've got their number one sponge finger all ready to be celebrating your death. You know, and you're just so retarded. But you'll talk to them. I mean, overt. anti-Semites, overt racists, overt chauvinists, overt every kind of negative thing a human being could be. These are the people that go and protest a gay man's freaking funeral, right? I mean, they're just too despicable. And look what he says. Always a friendly and hopefully something. I don't know what the hopefully was. Always be friendly. I mean, what a pile of hypocritical shit. But I am beyond the pale. I mean, I am just so much more evil, okay, than these preposterous bigots. Oh, it's just hilarious. No, I am scary, okay, because yes, exactly. You're gonna get your asses kicked in a conversation because you are fakes and phonies and frauds, and what you are doing is just making fun of people with mental disorders, and that's all you're doing on the internet. You're doing fail videos and laughing. You're morons, okay? You're not doing anything to empower the human understanding and get people to be grown-ups. No, you're doing exactly the opposite. You're just feeding the popcorn-eating drones. Period. Give the stupid morons. You're just like Google. You're just manipulating. You're just taking your graft out of the game, and then pretending you have something called honor or integrity. Disgusting. Okay, so the other turd of the, is the Simon Dan guy. So I did send him an email, not necessarily being insanely polite, just to the point. How much would you charge, for an interview where you have to defend conventional physics, at least the wave theory of light? And how much would you charge for you to post it on your channel? So, didn't answer the questions. Pulled the same exact thing as Conspiracy Catz. Oh no, I wouldn't normally charge for that. Well, that's the whole point, though. I'm not asking you, I'm not requesting you do me a favor. I'm not looking for some little happy fun thing, okay? I'm asking how much I have to pay you to defend your horseshit, to defend your behavior. That's what I'm asking you to do. The crap you preach, I'm asking you to defend it. All right, so it's like how else to say it? I mean, obviously, if you were going to do this fact-checking thing, obviously somebody who wants to fact-check you isn't asking for a friendly interview. It's going to be somewhat hostile. It's like Bohr asking Einstein, sort of thing, right? I mean, Einstein and Bohr didn't necessarily have to like each other to be able to debate physics, did they? No, they didn't. I don't know if they would have charged each other, but maybe it would have come to that. But $27 t-shirt. I mean, fucking A. With a little tiny thing on it. You pay more for the little tiny logo. Ugh, pathetic. So anyway, so I'm going to play this cruddy video, this energy storage. I was going to do it anyway. I got the email response this morning, but I was going to play this video anyway because it's a good video for me to illustrate the problem with their thinking process and just how thin it is and just how undeveloped it is. Just like a flat earther, they have flat physics. They have physics doesn't really have any air in it. It's not really, it's a flat tire. So he said, I won't, I think displaying the email would be an honest thing to do, but I won't do it because people get upset by that. So I'll just sit there and basically, read it, in a broken form. All right, so he says he wouldn't charge for something like that. And he says, I'm not as funny or eccentric as Ken Wheeler. So this is another, Ken Wheeler's an example of another despicable coward, just says bold and crazy things, maligns the dead. He's so much of a coward, he only picks on dead people. Just idiotic. And so therefore, it doesn't interest him. See, so he stated that because I'm not as funny and eccentric as Ken Wheeler, Yeah, well, fine. I see. I mean, he thinks again. What am I supposed to be dishonest and say? Oh, I think debunking flat earthers is just great. I mean, it shows that you're such really high-minded, high-intelligent people because you can beat the shit out of complete lunatics. You know, that's really some kind of boy. You really debated your ass off to beat up a lunatic. Okay. Gary, so as you sow shall you know, so he quoted the Bible at me. Yeah, exactly. I'm going to tell you people, get what you deserve, okay? Get the same kind of cowardice, this I'm going to malign you from a distance, I'm going to vaguely imply, I'm going to do all of this crap. You are slime balls. You have no fucking character. You have no fucking integrity. You're talking shit on the internet and you won't let somebody interrogate your shit, and it's that simple. And you know, for no price. I mean, isn't there some price you could come up with? $20,000? Couldn't you be as silly as Baldy Catz and come up with some kind of nutty answer like $700 an hour? Which I might even pay, actually, for a chance to take on somebody with 370,000 subscribers, 370,000 morons. But clearly in this video, you see he's doing some videos that are actual physics videos, right? And they get, you know, whatever, 15% of the views. So, I mean, people come to watch the mock the flat earther videos, but they're not too interested in this grammar school science you're capable of. And that's all it is. You know, it's, oh, I just read it out of the textbook. You know, no no respect for myself or, for that matter, Catz. So he said something as silly as that. Now, I didn't know they were friends, but yeah, on Katz's Twitter it does say Simon Dan. You know, so yeah, you know, but fine. Yeah, of course. I'm not pretending that I have some great respect. Obviously, I think all of physics is a corrupt pile of crap. I mean, you're a bunch of exaggerating, lying shysters in the sense that you preposterously exaggerate your reasons for believing this crap. Because the evidence isn't there. The evidence absolutely sucks, and you're pretending you have all this, you know, geological evidence and blah 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 blah. You're just as shit talky as the average tinfoil hat loony who starts talking about expanding Earths or something. You're the Ken Wheeler cowards. Why would I blah any time, waste any of my time on someone who thinks so little of me? Well, that's the whole point. That's the whole point. I'll pay you. I wasn't asking you for a favor. I wasn't asking, oh, let's all be buddies and have a nice fun conversation. Just that I wouldn't have a fun conversation with a member of the fucking lunatic Baptist church. What's fun about them trying to put people in jail? There's nothing fun about that. That ain't a fun subject. We weren't that far from it, you know. I mean, and you know, you just see how the politics changes, right? You get one lunatic in there because he has one issue, okay, where he's right and the liberals are completely wrong, and any kind of lunatic gets in there. And you got crazy judges now. So, I mean, what the fuck? We might be heading for that world, jackass. You know, and you think that's the kind of, oh yeah, let's have friendly conversations with fucking bigots who want to throw me in jail. I mean, you really are too fucking stupid. You know, to be mocking, you're almost too stupid to be mocking psychotics. Shit. And then he ends it with, you know, this jargon, respectfully something or other, and kindest regards and all this mush, you know, this cliche puke, you know, where everybody fakes, you know, dude, bro, you know, fuck you people in this coarse shit. You're so fucking dishonest. I'm not saying you should walk up to everybody and just say what you think, but god damn it, you can't even come close. Alright, so the opening rag completed, we'll get to the physics.
Hey guys, so last time out we looked at units and how those units can be represented with really, really large or really, really small numbers.
Yes, you have to have some units to measure things in. Yes, this much equals that much of something else, but it's always going to be a something else.
Today,
You have one standard somewhere, like the speed of light, and then you can measure all other time based on that standard.
we're going to introduce a really important part of physics, energy.
Yeah, it's not going to come close to explaining what the fuck it is or how the hell it works. But there's one statement that's just so glaring. Intros, I just so love them.
Hello everyone.
Oh, you're doing it again, so you already did that.
And welcome to Physics for All. So,
Yes, well, apparently most don't like it. So the physics for all is mostly fail. And you ought to take that as a sign of something. Oh, my audience doesn't really interested in physics. Yeah, no, they're just interested in me mocking morons.
energy. What do we know about energy? Well, first up, one of the key aspects of energy.
Really horrible jump cuts. I mean, it's really hard to. Like I said, I really haven't seen too many channels that are this poorly produced that get 370,000 subscribers. That's, not that easy to do. And you just wonder, what's the catch? What fucking video did he do to go viral to get all these subscribers?
Is that it is never, ever used up. It can.
So there we go. So isn't that a great statement? So that's exactly what I say, right? Energy is eternal. The little bits, the force, always moving the speed of light, and you just reconfigure the force in some other way, and it's always going somewhere. It's always pushing a piece of matter, or it's free flying through space. Those are the two places force can be. So force is, it's like the matter is balloons, okay? So it's nothing. Matter is just nothing. An electron is nothing, piece of nothing. And the something is the force. The force bits do it all. They push the matter, and if they're not pushing matter, that is, if they're not stuck on a piece of matter pushing it, then they're out here, okay, heading for some other piece to push it. And that's the key to the whole universe. And the matter displaces where force could be. See, force is here, 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 here. See, force has a density in the universe. There's so much of it. It could be that much. When a piece of matter is taking up space, what's it actually doing? It's displacing force. That means it's forcing force to be out here. So it's increasing the pressure outside, okay, by taking up space. By using the space, the force can't get to the space, therefore the force is forced to be in the space. And this is the conflict that is the nature of the universe. That's it. So energy is this stuff, little bit of this stuff. And it can be in all kinds of different forms that we all call some kind of field or force or, all that crap moving the speed of light. So if it's moving the speed of light, it's a piece of force. And it's been around. It's been somewhere before. It didn't just show up in the universe. No, it's been pushing crap for billions and billions and billions of years. So that's an important piece of physics that nobody talks about.
Only be transferred between different energy stores. And you can almost...
So calling them energy stores is just another way of saying it can be occupied moving a piece of matter. So obviously for something as simple, so for the simple movement of gravity, the argument is that when you have a bunch of matter, that is a bunch of electrons and protons, and you move them with force, okay, that is they are moving. Well, if they're moving this way, then that means they're occupying little force bits going that way. To move the electrons, the little force bits have to be stuck on the electrons. And that means there's a bunch of little force bits going this way that aren't in the universe anymore. And that's why over here it says, gee, there's nothing hitting me from this direction, but there's still a lot of stuff hitting me from the other direction. Therefore, I'm going to move in this direction, right? More stuff this way, less stuff hitting you this way. You're going to go this way. So your electrons and protons are going to get hit by more stuff going this way, so they're going to spend more time with a little bit stuck on this side rather than more time with a little bit stuck on this side. And so you can understand how the energy flows. But they don't do this. They have no connection. You know, they have this idea that, oh, it's conservational and it's circular, so to speak. But their circle has these huge gaps in it, for which they have no oh, it goes out and it comes back in again, you know. But their circle of force, their circle of energy, their cycle of it, the energy cycle, okay, they have no clue of getting of understanding it, because two of the most important energetic events that take place, gravity and magnetism, they don't think are forces. They don't come from anywhere. They don't think of them as energy.
Always account for it. When energy is...
So always account for it. No, you don't account for it. You don't account for it in the case of a magnet. You don't account for where the energy comes from. And you don't account for it in gravity. You don't account for where the energy comes from. All you do is say, well, it all equals out, because, you know, if something goes into gravity, well, it has to, you know, the energy gets used up going back out. So the energy you get going in, you have to give back, so to speak, going out. And so because the gravity system as a whole system is conservational, you still haven't explained where the first cause, where the energy went in. Okay, because you don't have any energy in the system.
Transferred, it happens via these energy stores.
So again, energy stores, just another way of saying that ping pong paddles with ping pong balls trapped between them. And that's really it. There's matter there's force that's occupied, okay, and there's force that's free.
And there are quite a lot of these energy stores.
That's right. Any kind of form of matter is going to store energy. Wherever a ping pong paddle is, wherever a piece of nothing is, okay, and there's two of them in some arrangement, as soon as you bring them together, you're storing energy in the sense that you're trapping it. You're making it have more interactions than it would have if it was in free space.
So we're going to go through those first. So here we have thermal energy, and this is basically how hot something is based on the movement of an object's particles.
Right, so he uses this term particle. Now we know, again, this is just so elemental to physics. You should never say the word, we should have never been taught to use the word particle for things that are composites. They're not particle, they're particles. So a human being or a glass of water is not a, you know, particle, water particle. Okay, even if you thought of it as atoms, you're still cheating, right? I mean, because it's, oh shit, I'm sorry about that. Oh, my drawings were pointless. What a horror. Anyway, you get it, I think. Anyway, if you think of it, atoms, you're still failing to understand the physics, right? Because the physics is always going to be about electrons and protons. And yes, neutrons are just electrons and protons stuck together. Okay. But they're the things that have to move. They're the things that are the particles, okay? And the other particle would be anything that's moving the speed of light, the force. And so light would be a composite of some particles of force, right? So those are particles. This is a particle. This is a particle. But the rest of this shit is not, a glass of water is not a particle. A glass of atoms is not particles. The particles are in the elements. Those are the real particles. So when you say thermal, what do you mean? Do you mean activity of, okay, big atoms? Okay, the atoms themselves are moving. Okay, moving about. So the big atoms moving. Or, more logically, you could understand, oh, are you talking about electrons that might be jiggling? Okay, moving this way, and then moving back this way, and then moving this way, and then moving that way. That's also heat. Okay, so the heat is really, okay, if you really want to understand heat, it's the electrons and the protons that are moving, that's the key part that's moving. The things inside the atoms, the electrons and protons, are moving. And if they move into each other, two atoms, what happens is the electrons interact with each other first. That's the biggest interaction that takes place, unless it's an ion. And of course, an ion is going to have an empty space, quite possibly a negative ion, and going to be much likely to connect to another piece of matter and create a bigger molecule. But that's what's taking place, a compound. But the heat is a representation of how much this stuff is moving. And how much it moves is dependent on how much force is bouncing back and forth between it and all that kind of crap. So how much density of matter, how close the electrons and protons are to each other is going to confine force and make the force more powerful, because the force now interacts with matter more often. Ping pong paddles. Energy. This much energy when the two particles are this far apart and they have a ping pong ball bouncing between them. I just moved them closer together. All of a sudden I created more pressure, more energy, because now they're interacting more often. That's the real answer. That's the real physics. This physics they're telling is just a story. It's Puss in Boots fantasy nonsense. Yeah, it's close to something real. I mean, we know what cats are, and but we know they don't run in boots and all that kind of stuff. So it has some elements of reality, but it's not real.
So, for example, a nice hot cup of coffee. Kinetic energy. Now this is basically the...
So, again, you don't need a hot cup of coffee. All you need is, let's say, atoms like uranium falling apart. That's also thermal energy. It ends up being
the energy of a moving object. So, an example for this would be someone running.
So again, somebody running, we know that this kinetic part is different pieces are moving at different moments in this process of running. So you're moving matter over time in a direction, but some of the matter is moving in different directions, and there's all kinds of inefficiencies. So it's not exactly the description of kinetic. Kinetic would be more like a pool ball rolling across the pool table. You want to make it as simple as possible. And so all kinetic really means is that you've got electrons and protons with energy stuck to them moving in a direction. You're moving them. To be moving them, that means they have to be absorbing a force that would be going somewhere else. And, that's the implication. And so now the mass of that energy is the mass of that particle.
Gravitational potential energy. Now this is the potential energy that something has due to being lifted to a height.
Right, so where did the potential come from? So again, he says, you can just follow this energy stuff from one place to another. You can only transfer it. So where did it collect the energy to be potential energy? Potential energy is implying I've built it up, I've stored it somewhere. How did I store it in gravity? Where's your theory? Where did it come from? Where was that energy the day before it was gravity? What was it doing that day before? So, and as soon as you ask that question, then you'll get the right answer. That the gravity has to be made out of something. That it had to be photons, or it had to be radiation of some other kind. It had to be some form of cosmic background radiation. It had to be some form of energy that made it possible for you to have this idea of potential. Now, I would argue that gravitational potential is nonsense. There's no potential energy in gravity. It is purely kinetic, okay? And it shows itself. You see it when you stick something in proximity to another piece of matter. You see the implications. But the only way gravity actually works is that something actually has to absorb the fact. It has to see the fact that there's more force hitting it from one side than the other side and be compelled to move towards something. And by moving towards it, it's doing the same thing to the other object. It's shielding it from force. And by shielding it from force, then it's going to shield back. And so it's just a shadow that grows stronger and stronger. a shadow of pressure. Matter absorbs pressure. It absorbs the energy. And so the energy had to be in some form the day before. The day before the gravity happened, there had to be that piece of energy that's moving those electrons was doing something else.
If I hold a book 2 meters from the ground, then that book has gravitational potential energy. If I lift it higher...
So again, no accounting for what that means. Where did that come from? Where's the cycle? Show me where it was running and then it became gravity. Show me where it was thermal and then it became gravity. Show me the conversion. They don't have that. They can't draw you that. They can't explain that. They've completely broken their own rule of conservation because they've made it into a magical bent space retard force. They've taken it out of the realm of all the other forces moving the speed of light. Even though they know it's moving the same speed as light, they've made it into something entirely different.
The gravitational potential energy will increase. Elastic potential energy.
So I can see why this wasn't exactly compelling to a lot of people. This is rather rudimentary. I mean, most people that know something about physics already know this shit.
Now this is energy stored.
So it technically should be inelastic, right? I mean, sort of, right? Elastic means kinetic, essentially, but okay, let's just play with it.
When an object is stretched or squashed. For example, an elastic band.
It's an inelastic band, but whatever.
Chemical energy. Now that is energy.
So again, that's just way understated, right? Just because those are obviously much more complex storage, but you could also understand that as being any kind of relationship that exists. So you have kinetic, which is kind of obvious. Pool ball hits pool ball, right? But what if I make the pool balls into magnets? Okay, then you can understand how this becomes elastic, right? Because there's more than one object. And the fact that there's more than one object means is that if I affect the object in a certain way, if I hit this with force and move it this way, that these two objects would end up, you know, feeling less pressure in a direction and end up swinging this way and this way. And so I've created some kind of machine that basically has the capacity to bounce back and forth into pressure. So I could take an atom and I could hit it with a force and compress it. So now it's been misshapen. Okay, and by missaping it, you know, having electrons that aren't of proportional distance, you know, this way is further away than this way, it will bounce back. It will say this force will increase because I've compressed it, and this force will want to decrease because I've expanded it artificially this way. And so when this relaxes, this will relax, and so that's something that's inelastic, and that it's capable of reshaping.
Energy that is stored within chemical bonds. A battery is a very good example here.
All right, but it's not an example in the sense you didn't really explain how chemistry stores the energy. So the complexity there is, well, is there storage in size, or is there storage? I would argue that density is a kind of storage. So the more densely compact the matter is, that is, the more electrons and protons you have in a certain amount of space, okay, that stores energy. So uranium, big giant atoms that have a very compact electrons and protons have more energy in them because there's more stuff, more pressure between the bits, because there's more bits occupying a certain amount of space. And so the chemicals that are capable of giving away energy are chemicals that have more than normal pressure versus chemicals that have less than normal pressure. So you could go to acids and bases, and you can go to positive and negative ions, and you can explain it lots of different ways. But again, he doesn't explain any of the mechanisms where you're adding or subtracting electrons. So when I make an atoms stick to each other, I'm essentially extracting electrons.
Magnetic energy. Now this is the energy.
So this one's funny, right? Just because I don't even know if I've heard that term, magnetic energy. Right? I should Google that, magnetic energy. What the hell would that be?
Between magnetic poles, whether repelling or attracting, and a compass is a good example for that.
So exactly how is it a good example? Because it makes compass needles move. Compasses make compasses move. I mean, there's no explanation of the real energy problem. The energy problem is that somehow magnets, okay, through the static mechanism, can obviously attract and repel. They can force other pieces of matter to move. Obviously, that's a transfer of energy. The trick is, though, where did the energy come from? And obviously, they have no clue. Okay, so, but I can give you a simple clue. Well, if you understand that the magnet isn't doing anything, it's a filter. It doesn't make anything. It doesn't make any Ken Wheeler swirly abouts and tornadoes. It doesn't do any of that crap. Okay, all it does is filter what comes in. So, purple force comes in, that is a mixture of red and blue, or if you thought of red as the north and blue as the south. Electron pressure versus proton pressure, because there's two forces. It's 2 plus 2 plus 2 physics. Two kinds of force, two kinds of matter, plus and minus, electron, proton, and two kinds of interaction. Okay, perpendicular exchange and forward exchange. Straight and 90 degree. And so with that simple 90 degree thing, like I said, the blue energy hits the bottom here and it reflects because this is blue. If red energy hits, it does the right turn, heads up north, and comes out this end. So you have red coming out this end, you have blue coming out this end, and therefore you have filtered the force, and therefore you can explain why objects that are likewise oriented, north and south, will, either move in or be pushed away. And the force came from the universe. The force didn't come from nowhere. The force came from the same place it comes from in gravity. It came from some place in the universe. Okay, it's in the universe. The fields are the force.
Electrostatic energy is the energy stored within repelling or attracting charges, such as storm clouds. The production.
So again, that is chemical. Essentially, it's pretty much the same argument. It's you're just talking about storing it in molecules. Charging, creating ions. That's what makes this chemical thing work, is ions. That's what makes clouds work, ions. Same damn thing.
Of lightning, etc. And finally, we have nuclear energy. And this is purely the energy stored in the nucleus of an atom, and the best example of
So again, it's not really in the nucleus of the atom, it's in the entire atom. The electrons are a key player in the function of atoms, and clearly yes, you have the atomic bits of the protons, you have the atomic bits of the neutrons, which are an electron and a proton, and then you have the electrons. And all of them are little pieces of energy that can be pushed. And the key fact is what's going to push them, though? What's going to push them is the energy that's stored in the relationship. So again, the machinery, okay, has a tension in it created by the fact that the electrons do hate each other. And the whole thing, again, is just about proximity. So if I can pile electrons together, the fact is they got a tremendous amount of force will build up between them, tension. And that is going to be compensated by the fact that between the electron and the proton, it's the opposite. Okay, all the force that would affect the electron, all the reflections can't happen. All the energy that reflects off electrons leaks out the proton, all the energy that leaks out the blah blah. And so, but that's the energy you're really releasing. That's the force you're really releasing. And when you release it, you end up pushing the electrons very fast, and you end up pushing the protons very fast out. And how do you do that? Well, you push them because there's force that has collected, and that force becomes a gamma ray or an X-ray, and that X-ray is really what's going to push the electrons and push the protons. They're going to be pushed by rays of force. They don't travel on their own. You can't shoot them like bullets and have them, fly into space forever. They don't hold momentum, because as they're traveling, as they're being pushed by a force, they're also moving into more force, and they will be dragged to a halt. But anyway, the point is that there's a lot of energy creating the magnetic tension between the electrons and the protons in the atom, and that energy bouncing back and forth is effectively what's going to be released.
Extracting that energy is nuclear power. Remember, the important thing is that the energy is always being transferred.
So he gave no explanation, again, of how it's transferred. So for the nuclear energy, you'd say, well, it was transferred inside of a sun. Okay, a sun had a tremendous amount of pressure, and the huge pressure inside the sun, okay, pressure means there's more force. Okay, so in that hugely dense force environment, these electrons and protons were arranged with each other. So it's like you made it inside of like say if I put two halves of a circle together, and I put those two halves together inside of a very high pressure vessel. Well, then when I take them out, they'll fly apart because I've trapped the pressure. Well, the same thing happened to these atoms. The key thing is they survived depressurization. Their arrangement, their geometry was such that when you took them from the deep water, the bottom of the ocean, and you brought them to the surface, yeah, they expanded, but they didn't break, and they remained a viable atom. But they're obviously not indestructible. They're more vulnerable to falling apart. So a certain environmental trigger, they get hit by two pieces of energy at the same time, Star Wars kind of thing, and they decay. They fall apart. You'll trigger you'll flatten the tire. They'll fall, I don't know.
And you can work out what sort of energy is being transferred through which different energy stores, and even figure out the wasted energy.
Right. So yes, the waste would always be just a different direction. So heat is really, so he does a video on conduction. Maybe I'll do that one. I mean, heat's very inefficient in moving. Electricity is very fast, right? So you're basically doing the same thing. You're moving electrons. But the key is when you heat something, the electrons are going in all kinds of directions. So instead of just going this way, the energy, the first electrons are moving this way. And somehow, because of the arrangement of the atoms, that gets converted into a lot of motion this way and that way in all kinds of ways. So it moves very slowly. But electricity, when the atoms are in the right arrangement, crystals, they convert that movement very efficiently in one direction. And so it moves very quickly. Same thing, really. Just that the same thing just happens to be in a slightly different form. Just like photons or electron energy with a frequency, a standard frequency. They've got dead spots between them, places where the electron moved away, didn't reflect anything to the world, and then places where the electron moved towards and reflected twice as much.
Something that we'll do in a later video. And the energy can be transferred in a variety of ways.
Right, so he didn't explain any of the transfers at all. He didn't explain where the energy was before it became gravity. He didn't explain where the energy was, where it came from when it became magnetic.
Mechanically, by an outside force doing work. Electrically, which is work done by a moving charge.
It's all work done by moving charge. Everything that we call anything called energy that we see has to do with moving electrons. There's no other way for the force to be real until it hits an electron or a proton. the force means nothing till it hits one.
By heating something, or by radiation, which is a form of kinetic energy.
Well, it's really not a form of kinetic energy any more than any of the other forms of energy. They're all moving electrons. If you don't move an electron, you haven't done anything. Electricity has to move them. Every form of energy moves electrons. And some of them move the protons too. So that's all the only difference. When you move the whole atom, you're obviously moving the protons too. But a ton of energy just has to do with moving electrons, changing their positions. Because changing their positions, the electrons are essentially connected to each other. They're connected to the universe. The electrons are always communicating with each other because there's always force between them that's bouncing back and forth, reflecting like mirrors. They always know where all the other mirrors are, so to speak. I mean, in a vague sense. Just like you're being affected by the sunlight from stars billions of light years away, they are heating you a little bit. They are moving your electrons a little bit. All the electrons are connected.
For example, light and sound. So we're going to finish off by looking at an example, and one of the easiest ones to think of is the energy transferred through heating. So if we take this boiling kettle as our...
So he says it's the easiest, and he doesn't even get to it. So he has electricity, whatever that is, right? So first we have to explain the electricity is the movement of electrons. So you're moving a bunch of electrons, and you're moving so many electrons that you're breaking the atoms. That is, you're ionizing them. And that's why they're glowing, is because they're falling apart. Little pieces are flying off of them. Just like the element of when you're going to create a cathode ray tube or doing this other stuff, you heat the element. The heat is basically saying, I'm going to break the atoms. So you're breaking atoms. Now you're not destroying them, you're just turning them ions, but turning them into an ion means you're going to release energy, you're going to release force. And so the force gets released by the fact that this element that you're shoving electricity through is degrading the atoms. The atoms are losing little pieces. The little pieces are now going to hit the other atoms in the water, and they're going to start moving those atoms. And they're going to move those atoms by moving the electrons and the protons. It's the only way to move the atom. You want the atom to move? You want a school of fish to move? You have to move the fish. The fish have to be given a reason to go in that direction.
Example, electrical energy from your socket at home is transferred to the thermal energy store of the heating element.
All right, so he says the thermal energy store. There's no storage there. The electricity is kinetic, and it's going to kinetically, it's not going to store in the heating element. It's going to go right through the heating element. It's going to go through the wire into the element. It's going to go to the surface where it's going to blow up the atoms. It's going to kill the atoms on the surface, ionize them. They're going to start glowing with radiation, and that radiation is going to start stimulating all the other atoms in the water. So he doesn't even get this right. I mean, it's elementary physics, and he doesn't even explain it technically accurately. But it's all very respectable. I mean, he's got an audience of 370,000 morons, and this is the best he can do?
Inside the kettle. Energy is then transferred to the water by heating. Into the...
Saying nothing, which doesn't say anything. You're supposed to be explaining heating, and you say heating. It's like a gravity well. The object falls into the gravity well because gravity pushes it down.
Water's thermal energy store, causing the temperature of that water to rise.
So it causes the electrons to move. That causes some of the protons and the atoms themselves to move. The atoms start to gain momentum. They start banging into each other, which means they're going to bang into each other's electrons, which is they're going to create higher pressure between the electrons, and then the electrons are going to spring back because they are inelastic.
The key is to remember that the energy is only ever transferred.
Right, okay, you said it again, but you didn't explain how it's only ever transferred. Because that's what that's really saying to everybody, is, which I think is the truth, is that you could mark it. You could mark a piece of energy. You know, let's say if we had a special kind of device and you could make one of them radioactive, a little piece of radioactive energy, and we could literally follow the energy. Okay, and we would realize that, yeah, they were like, you're full of stuff, and all that stuff was inside of dinosaurs, and it was inside of, all this stuff has been somewhere before. It's been doing stuff for billions of years. It could tell you one hell of a story. Yeah, and some of it's been stuck inside of an atom for a really long time and hasn't been doing much at all. It's probably not true that any of it ever gets stuck for a very long time, because as soon as the atom turns, it ends up collecting a new piece of energy that might have come from a sun, you know, a star, and it collects that new piece, and that new piece gets trapped for a while. So the energy never does get stuck for very long inside of an atom. It's probably never permanently stuck. But the idea is that you could watch the little piece of momentum flying through the universe, and you could understand that. Once you understand that, then you understand gravity has to be made of that too, and magnetism has to be made out of that too, because it's all moving the same speed. And then it just becomes obvious, and it works. The fact is it works. It explains gravity perfectly. It explains magnetism perfectly. Well, more completely than the current model by a long shot. It's so much better. And that's all they had to do, was believe what they say. If they actually believed what they say, then they'd say, oh shit, I'm saying this energy stuff never gets killed, and yet I haven't explained how it popped out of some magical grave to create gravity, and how it popped out of some magical grave to create magnetism. I have a bunch of zombie energy. Where did it come from? Where was it the day before? They never asked the question.
I cannot get that across enough.
Yeah, so these emphatic statements don't mean anything, because the video I was also going to play, you know, that I saw last night, I said, boy, I got a lot of videos to make, is another Feynman statement, you know, where Feynman's emphatically saying it's not a wave. Light is not a wave. He's emphatically stating it. And then I can play Professor Lewin emphatically stating the opposite. I mean, their physics is so broken, and they won't admit it. I mean, when you have two professors saying exactly the opposite and saying it emphatically, you have a problem.
And the way that we refer to it as transferring through different energy stores.
Right, so the word energy stores just makes it sound like there's some kind of package or box or, you know, some sort of storage. No, it's in the very function of the objects. They can't function without the energy. It all just collapses if there's no energy. If there's no ping pong balls moving, then there's no movement of the paddles.
Awesome. Well, now you should know all of the energy stores, and that energy can only be transferred between each of those stores.
And they didn't do anything to really explain that transference. And that transference always involves the movement of electrons and protons. And that's it. They're the element, they're the physics, they're the thing that does something, and everything else, all the other universes, the big universe with galaxies are still just electrons and protons moving. Electrons and protons make the galaxy look like a galaxy. It's not the other way around. The galaxy doesn't tell the electrons where to move. No, the electrons and protons, moved by the force, tell the galaxy where it's going to go. Physics is electrons, protons, and force. That's all it is.
Well done. Next time we're going to...
No, you didn't do very well. And you just talk like you answered a question and you have the right answer, and it's as silly as the religious answers. Because if I probe you a little bit to ask you about your demons and your hobgoblins and the rest of your dragons, you're just going to come up with more and more, well, the elves make them, you know, and the trolls sometimes eat the elves, and you're just going to have to come up with some kind of complete horseshit explanation, because you haven't really thought about it. You haven't thought about fixing it. You haven't thought about the fact that it isn't a good answer. It isn't complete. It doesn't actually fit the experiments. None of that crap has bothered any of you mohawks.
Expand on that and take a look at how energy is transferred by doing work. See you all then.
Yeah, what a pile of crap. So yes, I don't respect what you're doing. It doesn't change the fact that you should be accountable, and I should be able to, oblige you to defend your crap. And I'm being considerate enough to offer to compensate you, okay, for the unpleasantness of the adventure. And you won't even take that seriously. Because you're a coward, for fuck's sake. Like your friend Baldy Coward. Baldy less balls. Baldy no balls. Baldy no balls. Yeah, I like that. Alright. So I think that's probably enough for the day. What else does he say here? There's actually more video. Should we dare listen? Oh, credits. I love that too. God damn. Alright, anyway. So yeah, we will do some of this conduction thing and some of these other videos. Because this just shows how trivial their understanding is. How little they've thought about it. They just read, they got their lecture. They got told the story, the silly stories. And all they do is regurgitate the stories. And the stories are not very well thought out. They're bore stories, right? They're silly, wooey, magical stories. They're religious stories. Alright, so until the next time and such. I don't think there's anything else I have to do here. Is there anything else I'm forgetting? Did Google. Did Baldy no balls. Man Dan, whatever. Still a mystery, just amazing. I mean, I'm not saying this is like, I'm not trying to be critical. I mean, obviously the world runs on silly, what's the word you use? Trends, trendy things, style things, and those things are always changing. What's an attractive woman changes from decade to decade, that kind of thing. It's always changing. It's kind of arbitrary, it's just made up at the moment kind of crap. So maybe this is some sort of thing, like people kind of identify with this guy. I mean, he's not, I mean, I have to come up, it's not Brad Pitt, right? So, and, the videos aren't, highly well graphics and really styly, bangy, boom boom. There's nothing here. Crappy drawing of a toaster, that kind of thing. Well, I don't know if it's an electric kettle. Who the fuck uses electric kettles, by the way? I mean, you ought to do videos telling people don't use an electric kettle. I mean, it's just too stupid. Okay, I mean the gas is so much more efficient. So don't use electric. Electric heaters, really not a great idea. Alright, anyway. Should do that video. Anyway, yeah, so enough. Let's move along till the next time. I'll endeavor to persevere, endeavor to find someone with the balls and a brain. Two things that apparently don't go together too often. Yeah, we'll see what we can do. Yeah, like I said, I mean, this whole idea that somehow they have some reason to believe I'm like somehow we'd have the conversation, I would just go, you funny looking jackass. There's absolutely no evidence that I'd ever do that. I know what, tidy courtesies are. I can handle that. But they're just pretending like they have some reason to believe, like I said, that I'm somehow worse than a member of a Baptist church. That my integrity as a thinking person and as a person who can do logic and reasoning, make an argument, do all this stuff, I am worse at it, doing logic and thinking and being human than a member of a Baptist church. That's their theory of truth. That's one of the truths they're telling you. You really think that's true? Are you really that stupid? Only a member of a Baptist church could be that stupid. They're obviously cowards. Like Ken Wheeler. They don't want to have to defend their silly fucking physics, except against people who can't make an argument. Yeah. They'll do debates as long as they're not debating somebody who can debate. Who has something rational to debate. Okay. Such liars. Oh, I just don't feel like it. Yeah. I just don't feel like it. You're poopy. Yeah. It's just so funny, right? Why would you have a debate with somebody you agreed with? I have tremendous respect for you. Let's debate. What? Why would I debate somebody I have tremendous respect for? They were apparently doing things right, not wrong. Why would I debate that person? So he'll only debate people for which I have nothing to debate. All right, that makes sense, right?